Okay, today we're going to talk about the various features of a quadratic function. So in the graph here, we see a graph of a quadratic function. The shape of the quadratic is referred to as a parabola. And when you look at this quadratic, you will see that the quadratic is decreasing, and then at this point right here, it shifts and starts increasing. This would be a turning point on our graph, and it has a special name, and we call it the vertex. So the vertex is the point on the graph, on the quadratic, where it turns. It goes from increasing to decreasing or decreasing to increasing. So the vertex is a point, and the specific point is 2, -4. When we look at our quadratic, we can also see that our quadratic is going to have either a maximum or a minimum. In this case, the vertex is the very most minimum or lowest point on the graph. So our graph here has a minimum. Okay, it's located at 2, -4. But often you're going to be asked, what is the maximum, or in this case, minimum value of our quadratic? And when we talk about the minimum value, we're talking about the actual output. And in this case, you're looking at your y value, the output. So the minimum value is aligned to that y-axis is going to occur -4. So the minimum occurs at 2, -4, the point, but the actual minimum value or the minimum output is -4. Okay. The next thing that we want to look at are the different intercepts that occur with a quadratic. Okay. So first off being our x-intercept. All right, so our x-intercept is going to be where the graph crosses the x-axis. So this is my x-axis, and this is my y-axis. The graph is crossing the x-axis at these 2 points. It is when the y value is 0. So my x-intercepts are -2, 0 and 6, 0. Remember that x-intercepts are points. So you want to give your answer as an ordered pair. Similarly, the y-intercept is when our graph crosses the y-axis. This is going to occur right here. It is when the x value is 0. So on our graph, our y-intercept is 0, -3. Again, emphasizing that the y-intercept should be a point or an ordered pair. The next feature of a quadratic function is called the axis of symmetry. And the axis of symmetry is a vertical line that divides our parabola in half. So what we could end up doing is reflecting the parabola over that axis of symmetry line, and it would be symmetrical. Okay, that axis of symmetry is going to be a vertical line. It's always going to go through the vertex. So when we write the equation of the axis of symmetry, all of the x values, it's a vertical line, are going to equal the x value of that vertex. So our equation of our axis of symmetry is x equals 2. So the thing to remember is the axis of symmetry is a line, so you need to express your answer as an equation. All right. Just clean some things up here a little bit. Moving on. The next thing that we're going to talk about is the domain and range of our quadratic. So when we talk about domain, We are talking about all the possible x values. Now in our quadratic, I'd like you, even though you don't see it, to consider this to have arrows on it. So our quadratic is opening up, and it continues to open up, and as it's opening up, it's getting wider and wider. So what this is showing is as this quadratic grows, it's continuing to use all of the x values. So our domain is all real x values. And the way we would write that is our x values go from negative infinity to infinity. Range in this problem is a little bit different than the domain. Range refers to our y values. Okay, so what y values are being used in our quadratic? Well, for this particular quadratic, when we look at the y values being used, we can see that we're starting with the very lowest y values right here, and the graph is growing upwards. So it's continuing to use all of the y values as the graph increases. So the lowest y value that we are using is negative 4. And we continue to use the y values up to infinity. So my range of y values goes from negative 4 to infinity. The last thing that we are going to talk about is the interval of increasing and the interval of decreasing. And when we look at these intervals, we're going to look at the x values where the graph is increasing and the x values where the graph is decreasing. So let's start with increasing. So when I'm looking at the parabola, remember we talked before about the vertex being that turning point. Well, if we start at that vertex, the graph starts to increase right at that vertex and continue on in the positive direction of x. So looking at that x value, our graph starts at 2 and continues to increase to infinity. Now, when we look at when is the graph decreasing? So remember, that vertex is that turning point. So prior to the graph increasing, the graph is coming and decreasing. So it's decreasing all the way from negative infinity until that turning point. So we would say the interval of decreasing is from negative infinity until that turning point, the x value of 2. And these are all of the various features of a quadratic function.